It's my great pleasure. CEO of AOCS and moderator for today's session. Before I introduce our first speaker, I want to remind everyone that the session is closed to the panel discussion. Questions submitted during the session will be answered during that panel discussion. When submitting a question, please remember to indicate which speaker the question is for. Otherwise, it will be presented to the panel to address. I'm sorry, we're having some technical difficulties. We're working on that. Please indicate in the chat if you're still hearing the feedback from earlier. We'll continue to work on any technical issues we have, but as we're going to continue to plow ahead here, our keynote address will be delivered by Dr. Baljit. Dr. Ghotra has recently assumed the position as Senior Vice President of Food Innovation at Nature's Farm. Prior to this, he was the Vice President of Food Research for Appiagyei. In that role, he led ADM's strategic efforts, research and development. He spent more than 20 years in the industry working in research, manufacturing, and operations to build and leverage R&D platforms and to carry out end-to-end ingredient and product innovation. He has a successful track record of development that are based on simple science and engineering principles. Baljit, welcome. I look forward to your presentation entitled Reimagining the Future of Food.
For the introduction, I would like to begin by thanking the conference organizers for inviting me. Also thanking in advance the participants for their valuable time for this virtual meeting. For the next 20-25 minutes, I will talk about the importance of building sustainable food systems. I will also discuss the current state of agricultural technology that is undergoing a revolution which is shaping the future of food. We will discuss about the knowledge gaps as we look at creating delicious and nutritious food that are sustainable also. Wellness of people and the planet has never been more important. And we all have seen that more and more consumers are turning towards foods that are not only good for their health, but are also better for the planet. They are choosing every dollar they're spending on food very carefully. We also know that we will need significantly more food production by 2050 to feed 10 million people. This will put tremendous pressure on our natural resources, which we know are not infinite. We must disrupt the agri-food space, making the food production much more efficient than it is today by providing alternate ways to reduce the climate issues that we are facing today. In 2020, we witnessed severe climate issues around the globe. It is making climate and environmental issues very real. We have seen increasing incidences of hurricanes, wildfires, and floods in recent years. There were more than 100,000 fire alerts in Brazil during this summer, for instance. In the United States, we saw more than 5 million acres of land is burned due to wildfires. And on top of these climate changes and issues, COVID-19 pandemic has put our logistics and food safety through tough tests. We did not face such a magnitude of disruption in last 100 years. Food has always been taken for granted. But these times of crisis have forced us to rethink about food choices, food availability, and food knowledge. Consumer is much more learned to buy food that is good for their health. Convenience and on-the-go foods are on the rise. Food that boosts your health and immunity is on the rise. And lastly, the home-cooked food is getting creative during this pandemic, and it is on the rise as well. So all of these opportunities are there in front of agri-food processing industry to provide, by providing wider choices of foods to today's conscious consumer, because they want more. We all believe that agri-food tech sector needs to be highly efficient to reduce climate issues. The health experts and environmentalists have provided evidence on the benefits of reducing meat consumption. But despite this, meat consumption has been steadily going up, as shown here. Average consumer globally consumed about 43 kilograms of meat annually. In the United States, it's about 100 kilograms, while in India, it is about 5 kilograms a year. China consumes more than 80 million tons of meat a year, which is more than half of Asia's total consumption. And this shows that as the communities get richer, meat consumption tends to increase. And this is particularly an area where we see that there is a significant potential to reduce emissions, so that by reducing the dependence on animal-based products. Livestock production is reported to have the largest environmental impact on greenhouse gases, land use, and water use as well. Out of all, beef is shown to have much larger environmental impact than poultry. So in order to make agri-food production more efficient, we need to take into account on all of these opportunities that are in front of us that will help us to reduce our dependence on animal-based products. Agri-food sector is going through an unprecedented innovation, and this is something we all have seen in last decade. There has been more than 20 billion US dollar investments in 2019. Alternate protein sector alone has raised about 1.5 billion in the first 7 months of 2020. Before we look further into the disruptive innovations that's happening in this space, let's see an interesting study published in Lancet Public Health that is showing the importance of plant-based proteins in our diets. As a scientific community, we need to bring awareness on the importance of balanced diets and health. So this Lancet Public Health published an interesting meta-analysis on the importance of carbohydrates. A U-shaped mortality curve was reported, showing both high and low carbohydrate diets increased mortality. However, this meta-analysis also reported an interesting data on low carbohydrate diets, for instance, that were associated with dietary patterns that favor animal-derived proteins and fat consumption. In these subjects, high mortality rates were shown. On the other hand, low carbohydrate diets with non-animal protein and fat sources showed low mortality rates. High mortality rates due to increased animal protein and fat consumption have been hypothesized to stimulate inflammatory pathways, biological aging, and oxidative stress. Now let's switch gears and look at some of the innovations that is happening in alternate protein space. Alternate protein technologies are disrupting the conventional animal-based products that includes meat, dairy, and other convenience foods. Consumer has interest in different types of dietary proteins. Among these disruptive techniques, as shown here, microbial fermentation is shown to be highly efficient in producing proteins. Cellular agriculture is undergoing enormous amount of research and development. First cultured meat, a lab-grown burger was introduced in 2013. The technique at present time seems to be cost prohibitive, but a significant research that is undergoing in this space will pave the path for future. Lastly, the plant proteins, which we all know are the most well-established commodity in today's agri-food space. In recent years, soy proteins have shown a 6% reduced CAGR. And this is partly due to consumers seeking alternate options. They are seeking alternate options to allergens or anti-nutritionals or taste. And we have seen new plant proteins such as pea proteins are increasingly produced at commercial scale. Biotechnology can help improve crop traits to improve overall acceptability of plant proteins. This includes taste, color, anti-nutritional factors, and overall quality improvement of proteins, which remain a current challenge in plant protein space. Other technologies, such as the proteins from insects, are also there. But the reports are showing that they have been cost prohibitive in terms of making concentrates and isolates. Plant proteins and traditional agriculture will continue to play an important role in feeding the world. We also believe that plant proteins alone cannot independently meet the growing needs of our planet, as shown here on the graph on the left side. Soybean processing, as it is done today, is supporting the feed industry, while a small fraction of the total soybean produced in the United States is used for human food. As we look at the need for increased production of proteins to feed 10 billion people in 2050, new equipment and expanding human food use of soybean will be required. And this new equipment for soybean processing requires high capital deployment, which requires specialized equipment for many of the unit operations that we will look at in the following slides. There's also an opportunity of converting the animal feed plants to human food manufacturing, but that can also be challenging. But these are the challenges that also provide opportunity. How these changes can be made in a simple and cost-effective way to produce foods that are, for example, minimally processed based on ingredients that are less refined, for instance. And let's look at one of a typical ingredient label of a Generation 1 alternate meat burger to get deeper into what are those opportunities in terms of protein ingredients. First generation of alternate meat burgers are already sold commercially. Consumer has been debating whether they're healthy for us or not. A recently published clinical study at the Stanford University showed that, in fact, they're healthier than their meat counterparts. But consumers are questioning if plant-based meats are healthier from a standpoint of containing ultra-refined ingredients and a long list of food additives, as shown here on the left side. And these food additives and highly refined ingredients are added to deliver on texture, taste, and stability of these food products. Protein isolates, as highlighted here on the left side, are ultra-refined ingredients that are highly processed during the manufacturing to remove fats, carbohydrates, fibers from starting raw materials. And as product developers are formulating these ingredients into a burger patty, you can see the protein content of the finished product is about 17 to 20%. And product developers are adding back fats, carbohydrates, fibers, stabilizers that were just removed to make isolates. So the question is, can we make an ingredient which is minimally processed and wholesome and still delivers on simpler label and nutritiousness? That will also be a sustainable way to make ingredients at the manufacturing scale. Typical extraction process of obtaining protein concentrates and isolates is shown here. There are several techniques of extracting proteins. One of the examples that is used in industry today is for soybean processing, which we will look at the next slide. Soybean processing, as shown here on the flow chart, you can see it is a very complex unit operation. Soybeans are dehulled, cracked, followed by turning it into a meal or grits, which are further extracted by either expeller press or solvent extraction to take the crude oil out, which is further refined and used for human food use. Whereas the defatted flakes that contain the solvent still needs to be desolventized to turn it into white flakes, which are then further refined and processed in order to make highly purified protein ingredients, as in concentrates or isolates. As we think about making minimally processed soy proteins, a significant change will be required at plant level on these unit operations. There's a tremendous opportunity to simplify complex extraction technologies. For instance, minimally processing techniques that apply food-friendly solvents, for instance, could present a way to make food ingredients that are clean and also minimally processed. A simplified manufacturing operation tends to be low capital as well, so that they can be rapidly deployed to meet the growing needs of the population. And lastly, the sustainable manufacturing. Simple processes are known to be sustainable in a way of their water use as well as the energy consumption. So this is definitely one of the biggest opportunities in front of us. Now let's switch gears to discuss texture, taste, and nutrition, because we think it's very important to look at the underlying mechanisms that form these structures as shown in these food products that are based on proteins. Texture of food is a key contributor to a taste profile. We know that taste, nutrition, cost, and convenience are the key influencers for food choices. Since it is about food, not automobiles or iPhones, taste comes as #1 buying factor, while nutrition, cost, convenience are critical also. Consumers want tasty food that is healthy, not the other way around. Texture requirements are quite diverse based on the type of food, as shown here. They can range from solid foods, but that are still very high in liquids, such as meat patties, high moisture semi-solid foods like spreads, or low moisture foods like crackers or jerkies. So tremendous opportunity there as we look at these complex interaction of these ingredients that stabilize these unique structures. Broadly speaking, there are 3 pillars of innovation as we think about texture, taste, and nutrition. Consumer is comparing nutritional facts panel and ingredients list to make food choices. For product developers, knowing formulation alone is not enough, but understanding these ingredients, ingredient types, their interactions in complex food matrices is important. What is the role of ingredients in building a particular texture in food? This is an important question which product developers should ask, as it offers new techniques to design a food that will contain simpler, clean, and a short list of ingredients. The next innovation pillar is food processing technologies. New alternate protein ingredients require new methods of processing or improved methods of processing that industry is already adopting. This is to generate desired textures. This is definitely an area where a significant opportunity is there to innovate. For example, how to make fibrous filamentous structures to mimic meats. Extrusion is one of the processes that is industry-wide applied already, but there are ways to improve that process. But also there are some new processing technologies like wet spinning or shear cell, power heater, or other technologies where similar fibrous structures can also be made. But significant innovation is needed to bring these technologies at commercial scale. And of course, there are other structures in food, like cellular, micellar structures that are stabilized by interfacial forces, as in hydrogel or oleogel. Significant innovation potential is there as we look at these new ingredients that will disrupt the food space. And finally, it is about taste and nutrition. Taste is about aroma, appearance, mouthfeel, and flavor. Texture and flavor release is about how those food structures are deformed in mouth before ingestion. So more focused research needs to happen on that so that we look at changing the way food is formulated today. And lastly, how the food product is digested and absorbed in our GI tract is also important as we look at these alternative proteins, so that we look at creating alternative proteins that are bioavailable, that provide the right nutrition, but also good for the gut microbiome. Now, let me share about Nature's Fynd fungal protein technology that I mentioned earlier. At Nature's Fynd, we are delivering deliciousness and nutrition in food systems that are alternative to meat, dairy, and other convenience foods. Our company started when NASA, Montana State University, and Yellowstone National Park teamed up to study extremophiles at Yellowstone National Park. This is where we discovered an extraordinary microbiome, fungal microbiome, from Fusarium species, which was living in an acidic volcanic spring for thousands of years. We used that Fusarium species to perfect our novel fermentation process to create a protein that we call Phi protein. Phi protein has unparalleled combination of nutrition, texture, and taste as well. More than 50% of the Phi protein is proteins, and about 30% of it is dietary fibers. The proteins are of very high quality from a nutritional standpoint. It's a complete protein containing all 20 amino acids, including 9 essential amino acids, just like the animal-based proteins. 20-25% of those amino acids are branched-chain amino acids, which are essential for maintaining muscle structure. Talking about the fibers, these fibers not only provide the textural benefit, but also they are good for your immune system. These are beta-glucans that also has prebiotic fiber activity. And lastly, the essential vitamins and minerals, which are also present in the Phy protein. And these can provide up to 10% of the daily value based on 100 gram of Phy intake per day. Phy protein is neutrally dense, but it also provides more protein and fiber per calorie than the animal and plant protein counterparts, as shown here. And this is where the Phy protein provides us a way to make proteins or to produce proteins in a highly efficient manner. Phy protein provides us an opportunity to yield more protein per acre than animal and plant sources. As shown here, one of the example, if you compare Phy protein to beef production, about 800 kilogram of protein per acre is produced based on the fungal microbial fermentation technology, compared to 2 kilos of beef that will be produced per acre. So significantly less resources are consumed in this, more than 99% less greenhouse gases than beef, and more than 99% less land is consumed, is used compared to beef, and also significantly less water than what it will be required to produce beef. And we are doing this production all in Chicago, and is poised to scale in our 35,000 square feet facility that is located in the stockyards, Union Stockyards in Chicago. So we are building a global alternate protein brand across product segments and geographies. With this, I would like to conclude that alternative proteins are at exciting phase of growth in this new field of agriculture that will sustainably feed the world while reducing the climate issues. Thank you so much for listening to me and giving me an opportunity to share my views. Thank you.
Well, I think we have our audio challenges taken care of, and thank you, Baljit, for such an excellent presentation. You've certainly given us a lot to think about. The challenges are many, and I guess I'm going to ask you perhaps an unanswerable question, but thinking back in your experience in companies like ADM and then applying all that you've learned and seen and know, and now let's say that I'm a small to medium processor in Africa, and you've just shared all these challenges and opportunities with me. Where do I start? What do I focus my attention on? It seems almost overwhelming.
Yeah, no, excellent question, Patrick. I mean, disruptive technologies, they always look like to implement a disruptive technology, it's not simple, it's not easy. Otherwise, it would have been done already. But I think we all have to look at these new technologies. Even if we start small, we have to start somewhere. But the disruption begins to happen right when you take the first step. And it is a first step so far. We built a 35,000 square feet facility that will produce significant amount of significant amount of protein-rich ingredients, which compared to, if you look at agriculture, you will need more than 15, 20 acres of land. So I think if we look at how this agriculture needs to be transformed is by minimizing the land use, minimizing the water use. And I think the disruption will happen. But you're right. How to bring that change, I think everyone has a role to play here. We need support from the local governments. We need support from the local industry to make that change happen, that we call the first step.
Great. Well, thank you. And, don't forget that we'll close the session with a panel discussion. So submit your questions using the chat feature. Your questions will be answered during that panel discussion. And when submitting a question, please remember, if you can, to indicate the speaker the question's for. Otherwise, it'll be presented to the panel to address. Okay, moving on to our second presentation, analyzing seed composition in the Pan-African soybean variety trials and determining seed protein and oil content for Pan-African trials via NIR spectroscopy. This talk will be given by Andrew Scaboo and Liz Prenger. Dr. Andrew Scaboo is an assistant professor in the Division of Plant Sciences at the University of Missouri, located in Columbia, Missouri. He was born and raised on the East Coast of the United States in Salisbury, Maryland. From there, he traveled to the University of Tennessee for both his bachelor's degree and his Master of Science degree in Plant Sciences and Breeding. He continued his education at the University of Arkansas, where he received his Ph.D. during the spring of 2011. After a year-long postdoctoral position at the USDA ARS in Raleigh, North Carolina, Dr. Scaboo started at his position at the University of Missouri, where he leads the soybean breeding and genetics research team in Columbia, Missouri. During the past 6 years, Dr. Scaboo has released many soybean varieties and germplasm lines. And these releases are currently grown by farmers and or licensed to private companies for their use in breeding programs. Dr. Scaboo has co-authored, refereed journal articles and 2 book chapters, and is currently involved in numerous state, regional, national, and international collaborative research projects concerning soybean breeding. His research largely focuses on improving soybean breeding for variety development, genetic diversity, disease resistance, and improved seed compositional traits. Liz Prenger is the Senior Research Specialist with Dr. Andrew Scaboo's soybean breeding and genetics research program at the University of Missouri. She's worked for the University of Missouri soybean breeding program as an undergraduate until graduating with her bachelor's degree in plant sciences. She then earned her Master of Science degree in soybean breeding and genetics from the University of Georgia, where her research focused on genetics of soybean composition. Liz returned to Missouri and the University of Missouri soybean breeding program in 2019. She is currently responsible for managing the analytical lab chemistry, high performance liquid chromatography, and gas chromatography, managing data analysis for the program, and managing near infrared spectroscopy lab. Andrew and Liz, take it away.
Thank you, Patrick, for the introduction. And as mentioned, my name is Liz Prenger, and I'm going to introduce soybeans briefly and then talk about the technical aspects of near-infrared spectroscopy. A typical soybean seed in the United States contains about 19% oil and 34% protein, and this is reported on a 13% moisture basis. So if that were to be converted to a dry matter basis, it's about 22% oil and 39% protein. The protein is one component that makes up the soybean meal, along with fiber, soluble carbohydrates, and minerals. In the United States, soybean meal is largely used for livestock feed, and oil goes into production of vegetable oil. Worldwide, soybean meal is the #1 source of protein meal and the second largest source of vegetable oil. As far as Sub-Saharan Africa, there's a lot of potential for use of soybeans in the growing poultry sector, as well as for producing quality vegetable oil. For the past several decades, soybean genetics of seed composition have been studied, especially protein. And at least in the US, we have a fairly good understanding of genetics of seed composition and how these different seed components affect one another in yield. But there still is a need to study genetics of seed composition in places such as Africa. So next, we have methods of determining seed composition. So one method of determining seed composition is through wet chemistry and analytical chemistry. And these methods are very slow and expensive. It takes several days to prepare samples, ship them to another lab, or to do them in-house. And it can be expensive to get the data back as well. Another method, which is much faster and inexpensive, is near-infrared spectroscopy. So wet chemistry and analytical chemistry have high precision and accuracy, and near-infrared spectroscopy, since it is much faster, it also has relatively good precision and accuracy. On this slide here, we have the two machines that we have in-house at the University of Missouri soybean breeding program. On the left is a FOSS NIR machine, and it is a transmittance-based detection system. So it detects at a larger wavelength range from 400 to 2500 nanometers. And on the right, we have the Perton DA7250, which is a reflectance-based system, and therefore detects at a smaller range of wavelengths from 950 to 1650 nanometers. So both of these machines, maintenance is typically, it involves maintaining the light bulbs, making sure they're performing correctly, as well as maintaining the equations used to determine seed composition. And between these two machines in particular, there's about a 10 times difference in the speed of analysis for a single sample. So next. So we use near-infrared spectroscopy, or NIR, to determine seed composition of various soybean samples. And when done on whole soybean seeds, it is rapid and non-destructive. We can reuse the seeds for any other purpose. The machine that was on the previous slide, the Perton DA7250, is becoming very popular among breeders and researchers in North America. Many different research programs here have one of these machines. And the instrument calibration for this machine uses thousands of samples with known seed composition that was determined through analytical chemistry and wet chemistry methods. And this machine is ideal for high throughput phenotyping for our breeding programs here and around the world, as well as for processors and producers who need to know the composition of the product they have. Next. So here we have listed the AOCS protocols that are used for analytical chemistry and determining the calibration for determining seed composition. So we here at the University of Missouri are part of a consortium among public breeding programs that helped contribute to the improvement of a calibration for our machines. And that effort is led by the University of Minnesota. And the wet chemistry and analytical chemistry are done at the Eurofins Discovery Labs for at least for total oil, crude fiber, moisture, and crude protein. And in-house, sometimes we will do our analytical chemistry for fatty acids and for sugars with the AOCS methods shown below. Next. Here we have calibration statistics for the 2020 soybean calibration. And at the top, you can see the parameters, moisture, protein, and oil, with in the graph highlighted the R-squared of cross-validation. So you can see for these parameters, there's a high proportion of variance predicted, greater than 86% for oil, protein, and moisture. And that was developed with over 5,000 samples for each parameter, and that's highlighted at the bottom of the graph. And you can also see there's a pretty large range of sample values that were used to develop the calibration for moisture from 4 to 19%, protein from 32.6 to 53.6, and oil from 13.6 to 26.5. Next. And this slide shows the same statistics for the fatty acids in soybeans, so oleic, linoleic, linolenic, palmitic, and stearic. And these also have a fairly high R-squared value, especially for oleic, linoleic, linolenic, and palmitic. Stearic is a little lower, but for each of these parameters, over 7,000 samples were used in the development of the calibration. Next. Here we have the protein calibration details, and this is from the 2019 calibration. So on the top, we have a graph showing the reference versus the prediction, and it shows the accuracy of determining seed composition protein for a single sample, and each of those dots represents a single sample. And on the bottom, you can see the distribution of those samples as far as protein content. So it ranges from anywhere 33.4 all the way to 53.6%, and that is all included in that calibration. So next we have the same statistics for oil calibration. Yeah, and again, you can see reference versus prediction. It's a fairly tight line there, high accuracy. And again, you can see the distribution of that lab data from 13.6% to 26.5%. Next. So here I will walk you through, this is our actual Pertin DA 7250 NIR machine, and I can walk you through using these photos how we run a sample. So in front of us is, on the right, we have a polystyrene block, which we use as a check to make sure the machine and the light are working, the lamp are working correctly. Above that is a barcode scanner, which we use to scan barcodes on our seed sample envelopes to help eliminate human error when we are processing these samples. And then on the left side of the NIR machine, we have our sample dish and a dish for, or a bar for striking off the sample. So next. So after we've run that polystyrene check to make sure everything is running correctly, we are able to load our sample, as you can see in the cup. And we have in front of us, there's an envelope with a barcode and all the various information for the sample which we are about to run. Next slide. So here you can see we strike the top of the sample cup to make sure the sample is level. We stick it under the light in the machine, and then we hit the Analyze button. And at that point, we're able to use the barcode scanner to scan that barcode in the upper left corner of the envelope. And very quickly, that information shows up on the screen. And then we run the sample. It takes about 6 seconds after that point, and all of the parameters shown in the top right of the slide show up on screen, and you can kind of quickly glance and see how things look. And at that point, you are done, and you can repeat the entire process. So if you're going pretty quickly and you're in a, you can analyze a sample in about 30 seconds total between dumping it into the cup, striking it off, and getting results back from the machine. So next, I'll turn it over to Andrew, and he'll talk about some of the results from the Pan-African trials.
Okay, good. I'd like to start off by thanking the organizers for allowing us to talk about the research and the Soybean Innovation Lab. Patrick for the nice introduction. And I'd especially like to thank Liz. I think everyone knows how much team members are part of a good research lab, and Liz is no exception to that. She's a great student. She was a great student, and she's also a great technician in our lab that runs our analytical chemistry lab and our spectroscopy lab. Okay, so I want to finish up, and if it looks like we have enough time to get through what I want to get through. I don't know if we're running late, but I'd like to now talk about the Soybean Innovation Lab. And Soybean Innovation Lab, the PI is Dr. Peter Goldsmith. He's at the University of Illinois. And the Soybean Innovation Lab is a Feed the Future Innovation Lab funded through USAID. We have been an innovation lab now for about 7 or 8 years since inception. And we have a website that was newly created that you can go and visit. It is Soybean Innovation Lab at .illinois.edu. And we have a lot of great information about all the wonderful things we do. I'm just going to talk a little bit about the managed research area. We have 10 managed research areas. Dr. Brian Deers, myself, and 3 breeders in Africa, Dr. Denwar, Dr. Tesfaye, and Dr. Chigizi. We work on the managed research area 1, which is plant breeding and germplasm management. So the motivation and justification for our managed research area, breeding germplasm, is to improve soybean in Africa, knowing that plant breeding is a foundation of a productive agricultural system there in Africa. So we have to have a strong plant breeding and variety and cultivar development system to ensure the continued progress of the soybean in Africa. We have 3 really major issues that we tackle through breeding. One is the low nutrient availability in Africa. The soybean is a legume, and you can fix nitrogen. There are highly acidic soils with low nutrient availability, so that's a major issue that we have to tackle for breeding. And one of the other things that we're going to talk about today is protein and oil, right? So malnutrition is still a problem in many areas in Africa. And our first speaker really did a good job highlighting how plant-based protein is really making a shift in the market. And this is also the case in Africa, where soybean can be a very important source of protein and vitamins for the entire value chain in Africa. So besides our nutrient availability and understanding the market for protein as well as protein for the poultry industry and for human consumption, as well as the oil for human consumption, farmers worry about yield, right? So probably our #1 priority is to develop those higher yielding soybean varieties that will be an important part of the value chain there in Africa. This graph just depicts from FAO website. Here in the yellow, green, gray, and orange, those are the top 4 producing soybean producing countries in Africa. And I just want to highlight that even today, only South Africa is developing soybean, or has soybean production that is close to equivalent to the US and Brazil, which is the world leaders in soybean production. So the US is in red, Brazil is in blue. And as you can see, even today, most of the countries, Uganda, Nigeria, Malawi, are still below the yields that we had in the US and Brazil in the 1960s. So there's a lot of different reasons for this, but one of the main reasons that we tackle, as I suggested, is just developing improved varieties. So our objectives, we work directly with the International Institute for Tropical Agriculture and the breeder there, as well as private seed companies such as Seedco. And we want to increase the soybean breeding capacity and improve soybean breeding practices in our target countries. So we've done a lot of things, like we've improved mechanization, we have introduced new germplasm, we have updated a lot of their facilities, as well as techniques and the entire process of breeding. We have just built the capacity in our country, and it's done a lot of we've made a lot of progress over the last 6 or 7 years, with new varieties being released every year from our partners in Africa now. Okay, so the partners that we work with are in, we have a lot of partners that we work with, but for our breeding, we mainly focus on Appiagyei, Erie, and Sari, and that is located in Ghana, Ethiopia, and the hub station for Appiagyei for soybean breeding is in Zambia. So we partner with the breeders there, and we have done a lot of capacity building in each one of these countries. And our main partner, and it always boggles my mind how much Godfrey does, but Godfrey is down here. They just built this. This picture is the hub facility there in Zambia, in Lusaka. And his target region is the entire whole of Southern Africa. So he's developing soybean, and Appiagyei is developing soybean varieties for the entire whole of Southern Africa, 8 different countries down here. So he has a big region where, my program, we develop soybeans mainly in a strip of our maturity groups. So Godfrey has a big program, and his program's really grown in the last 7 years with our help. Okay, so I have this picture on here because this was a trip that we went on in 2015 to Zambia and Malawi, and we visited a lot of different, this is Godfrey here on the top right, the retired curator of the United States soybean germplasm collection, Dr. Randall Nelson, and then Brian Deers. And the reason I put these pictures up is because this trip was the trip where Brian, Randy, and Godfrey and myself developed the idea for the Pan-African trials. So we just thought this would be a really good program to set up here in Africa, where we can continue the effort of supporting the value chain beyond breeding. So I'm a breeder, genetics, that's what I'm interested in, that's what my research focuses on. But the next step is getting released varieties to farmers to process and eventually to processors and producers, and understanding what processors and producers need, as well as farmers, to develop new breeding lines. So the idea of the Pan-African trials is to support soybean adoption in Africa by bringing high-yielding soybean lines to the African market through connections in the Pan-African trials among breeders, trial operators, and seed companies. So this little pyramid of working with local seed companies at the top, those are the people who are going to introduce and sell new soybean varieties, along as working with the breeders who are developing those varieties, and then working with the farmers who are growing those varieties. So we want to understand the seed sales for the local companies. We want to understand what the farmers' needs are in production. And then we want to be able to efficiently and we want to be able to develop soybean varieties in the most efficient manner possible with the resources that we're given. So that's really the idea around the Pan-African trials. So we started in, I believe, 3 countries back in 2015, and now that we're in over 21. So we're in Sudan, Ethiopia, Uganda, Kenya, Rwanda, Burundi, Tanzania, Malawi, Mozambique, all over the African continent now. In each one of these countries, we have cooperators who we work with who plant the trials, collect the data, and then for the last couple of years, they actually package the seed and they send the seed back to our lab where we analyze seed composition. So in 2021, it looks like we're going to be in a total of 27 countries now, where we're planting these Pan-African trials, evaluating agronomic performance as well as seed composition to understand which varieties fit into each country. And as you can see, the number of locations has dramatically increased over the last 5 or 6 years. So what does the Pan-African trials do? We really want to enable higher yielding soybeans to get to the market, to get to farmers' fields, because that's really the challenge in breeding, is you can breed and you can develop new varieties with important value-added traits, such as improved protein or improved oil or higher yielding, improved disease resistance. But to have an impact, those varieties have to get to the market. And so, again, the Pan-African trials put together all those people, the farmers, the seed companies, as well as our public institutes like Appiagyei and the actual breeders who are developing those varieties. So far, just in the short 5 years through the Pan-African trials, they've registered 5 different soybean varieties. Currently, there's 15 different soybean lines that are being registered. When we say registered, mean they're able to be sold by seed companies in countries. And that's happening right now across 7 different countries. So we've also, as scientists, we leverage a lot of the Pan-African trial data. We look at G by E, genotype by environment analysis. We're doing some different soil analysis. We have started a major genotyping effort to understand and develop different breeding and selection strategies. We have developed a disease analysis and monitoring where we train and educate farmers as well as technicians on how to recognize disease, how to take notes on diseases. And then we do our grain analysis, which is we understand protein and oil. So I'm going to finish up my presentation today talking about our protein and oil. And I'd just like to highlight a couple of our reports. So every time we finish up a location, we collect all the data, analyze the data, get all of the composition data. We post a report on the Pan-African Trials website that is publicly available for anyone to look at. And this is what our reports look like. So this is the first page. It's kind of a summary, an overall summary. This particular report is the results from Malawi and Zambia from the summer 2018 and 2019 trials. And this data is really focusing on the protein and oil concentration. So we have a little map that shows the sites for this particular trial, some pictures of the trials while they were growing. The next page here shows our table across sites, and what we do is we just take a regular mean, LS mean, and we do a rudimentary analysis and give the mean, the average, the LSD, the CV for the test location, if the genotypes were significant and if there was significant G/E interaction. So my next slide kind of shows a little better this table that we give, and I'm not going to go through all the individual data. I do want to highlight a couple things. The first is the source column. So this shows you all the different sources of where varieties come from that go into the Pan-African trials. So we have private company such as Seedco, publicly available through IITA, as well as DARS, other smaller seed companies, MRIA Seeds, the University of Makerere, South Panorama. So we have a lot of different entities who want to submit soybean lines to be evaluated in the Pan-African trials. So we list the yield potential in tons per hectare for each individual variety. In this particular example, Seedco's variety Signal was the top yielding variety. And then we have the mean across all of our sites for this year. That was 5 in this case, and we have the protein and oil listed. And then for this report, we list the protein and oil individually for each variety at each location. And what I want to point out here is the dramatic changes that we see in protein concentration due to the environment. So if we look at the mean down right here, you can see that there is a range between 33% protein all the way up to 41% protein. So we're talking about an 8 percentage point difference in total protein content in the seed just due to the environment in which these trials were grown. And we know from research here in the US that soybean seed composition is dependent on environment and can change largely due to nighttime temperatures and when that seed is maturing and proteins and oils and seed constituents are being translocated to the seed. That's very much dependent on the temperature as well as other nutrient availability during the nighttime when seeds are maturating. So that's also a really important and valuable aspect. Again, as our first speaker discussed, as we make this transition into a more plant-based protein, we really have to understand which environments and which varieties perform the best when protein and oil is the main goal at the end of the day for a processor. Okay. So then we also break down. It was interesting. Again, the first presenter had a good slide on the difference in their technology and different animals and plants produced per hectare. So what we do also in our reports is we produce a table that looks like this, and we calculate the tons of oil per hectare in relation to the seed composition and yield. And then we produce the tons of protein per hectare. And what you can see is we have a lot of variation. So this is really valuable information for processors as well as end users to use in selecting soybean varieties to be grown in specific environments and specific countries across the African continent. And then we have our last page showcases contacts. So if you're interested in any of these varieties, the contact information is there. The last one I want to go over real quick is a report from Ghana. And this was done in 2019 So and I just want to show that our reports are set up in a very similar way each time. The one thing I do want to highlight, I don't know how much time I have left, is that one thing we see in Africa that has been in the US, that is very well established, is this genetic correlation as well as phenotypic correlation between the amount of protein in a soybean seed and the amount of yield. And that is a strong negative correlation there in the US. And there's been several published papers recently that showed as soybean breeders, as we increase the yield of a soybean variety by improving the genetics, because of this correlation here, we are actually decreasing the amount of protein in the seed, and we're increasing the amount of oil. So there's a negative correlation between protein and oil, as well as between protein and yield, but a positive correlation between oil percentage and yield. And we just did a quick, we haven't published things, we're still collecting all the data and looking at these to understand this relationship in Africa, but we do see the same trend with, and this is just from Ghana, but we've looked at this as several other countries, and we do see this slight trend where as you increase the amount of yield that's produced, you are decreasing the amount of protein. And oil seems to not change much in Africa. And this is a little more dramatic in the US. I think that's largely because our yields are much higher. But this relationship is important to understand when developing new varieties that have this value-added package of increased protein or increased oil. There is a genetic consequence to increasing or changing seed composition when we think of agronomic traits, particularly yield potential. Okay, so I just want to summarize. We get a lot of data from our Pan-African trials, and I want to highlight here, we do have a website. And I also want to highlight Michelle dos Santos. She is the manager for the Pan-African trials, and she just does an incredible job on organizing all the data and putting together those reports. And if you're interested in any of these data, any of the reports, learning more about the Pan-African trials, you can visit our website. That's panafricantrials.com. And I hope I'm not too late, but I think I will end it there.
Thank you so much for that presentation and wealth of data that you shared. Spent some time getting our heads around all that, and we'll certainly have time in the panel discussion at the end to dig in deeper to that. Just one quick question before we move on to our next speaker. You had 5 lines that have been registered since 2015. And you have a number of 15 more in the queue and then a bunch more in the field still. What's the timeline for registering a line? When you make that decision, this line is viable and you want to get the seed registered, what's generally the timeline you can expect for that to happen?
Well, to answer that, I think there's there's the process of collecting, and I'll start by saying it varies from country to country. Mm-hmm. So each country has their own entity that is involved in the release of crop varieties. And it's usually a committee-based decision, and it varies from country to country. But the first part is collecting enough data to have a confident, to have the ability and confidence to say this is a good, great performing soybean variety that deserves release. And that process can take anywhere from 2 to 5 years, just to collect enough data. Again, depending on the country and what the release committee needs as far as data. Maybe it's 30 environments, or maybe it's on-farm trials. But to answer your question, the Pan-African trials aids in collecting that data, right? So it's a process where breeders and maybe an institute like IITA doesn't have the resources or capacity to do this wide-scale testing. So it's really a collaborative effort to collect enough data to then go to each country's release entity, give them the data and say, here's our package. We believe this is a viable release. And then they make the decision, yes, this is a viable release. Once that happens, then we have to go through the process of seed multiplication and getting that seed into a viable seed, good quality, high quality seed to the people who are going to sell it. That process usually happens pretty quickly, within a year. Once the longest process is collecting that data. And that can take, like I said, anywhere from 2 to 5 years to collect enough data to have confidence that this is going to be worthy of release. But once that happens, it can go pretty quickly. It's more paperwork and decision. Yeah.
Terrific, thank you. And we'll pick this up again, I think during the panel discussion. There's a lot more questions and a lot more information to dig into here. So thank you again very much for your excellent presentation.
Thanks, Patrick.
And to the audience, please, again, don't forget, we'll close the session with this panel discussion. So please submit your questions using the chat feature, and we'll try to get to those during the panel discussion. And just as a reminder, when you're submitting your question, if you can remember to indicate the speaker, that'll help in directing the question to the right spot. Okay, our third presentation will be by Dr. Kerry Clark and Jeffry Appiagyei. And it's entitled Improving Grain Access and Availability for Processors Through Thresher Technology Support and Impact of Locally Manufactured Threshers in the Soybean Value Chain. And we'll be we'll be looking at that presentation momentarily.
Hello, I'm Kerry Clark from the Soybean Innovation Lab, and I'm joined today by Jeffry Appiagyei from SayeTech, Ghana. I'm sorry that we're not able to be with you in person during the slideshow, but we will join in person for the question and answer period afterwards. The topic we would like to discuss with you today is how you can improve access to grain through support of mechanical threshers. When the Soybean Innovation Lab started working in soybean production in Sub-Saharan Africa back in 2014, we quickly heard from producers that the lack of threshing capacity was a major constraint to increased production of soybean. Hand threshing of many crops is the norm across Africa, but is extremely labor intensive and it slows down post-harvest grain marketing. Hand threshing limits the amount of land a farmer can produce on because it is hard labor that is time consuming. Hand threshing increases the incidence of contamination and pathogens. This photo is from a soy food production facility in Ghana and shows the amount of stones and wasted grain that is present after grain is cleaned. An important result of mechanical threshing is the reduction of dirt and stones in the grain. Contamination during stick threshing makes local grain less desirable to processors. Reduction in cleaning needs for processors can allow for price premiums for clean grain. When farmers use mechanical threshing and the machine is properly adjusted, a machine like the Soybean Innovation Lab multi-crop thresher can remove most chaff. Field studies showed average chaff by weight in soybean was 1.8%, which is under the industry standard of 2% chaff by weight. Maize and rice had even lower chaff by weight at 0.1 and 0.3%. And of course, when the crop is no longer threshed on the ground, there is complete elimination of stones and dirt. SIL has partnered with processors and fabricators to introduce a high-efficiency, locally manufactured multi-crop thresher for Africa. SILS provided manufacturing training in 10 countries, including Kenya, Tanzania, Zambia, Zimbabwe, Ethiopia, Rwanda, Burundi, Ghana, Uganda, and Malawi. The photo on this slide shows a high-quality thresher built by SayeTech in Ghana. Part of the SIL process of training local fabricators includes adhering to high-quality standards. The SIL multi-crop thresher has been field tested with farmers over the past 4 years, leading to a design evolution that has addressed the needs of multiple users working in multiple crops. We've made significant design modifications as a result of feedback from numerous stakeholders in 9 countries. These include things such as adding secondary cleaning for better chaff removal, improving our trailer for roadworthiness, and adding a straw puller to make soybean feed faster. After testing multiple sizes and business plans, we concluded that a thresher sized to provide profitable business income for service providers was the best path to scaled-up thresher manufacturing and use in most African countries. The SIL multi-crop thresher is sized to create income for service provision businesses. It threshes maize, soybean, millet, sorghum, rice, cowpea, common bean, pigeon pea, barley, wheat, sunflower, and many other crops. It threshes groundnut, but it breaks them, so we don't recommend it for groundnut at this time. It can thresh very small grains with the suction disconnected so that the grain is not lost with the chaff, and this would include crops such as teff, chia, fonio. Due to the ability to quickly load maize and other crops where the grain is concentrated on one part of the plant, maize, rice, sorghum, and millet have very high threshing capacity in the SIL multi-crop thresher. Soybean capacity is only about 1/10 that of maize due to the necessity of feeding the entire soybean plant into the machine. This slower feeding of soybean compared to maize is found in all thresher models and not just the SIL multi-crop thresher. The SIL multi-crop thresher averages 2 to 3 tons of maize and rice per hour, 1.5 to 2 tons per hour of sorghum, millet, and beans, where the pods have been removed from the plant, and just under 300 kilograms per hour of soybean, which is slower due to the need to feed the entire plant into the thresher. The price of the machine in each country is driven by cost of raw materials in that country. The price ranges anywhere from $2,500 to $4,000 in 2020. But if you compare that to the price of imports, that imported thresher of a comparable size and capacity ranges anywhere from $8,000 to $30,000. The Soybean Innovation Lab multi-crop thresher is made of heavy-duty metal. It can potentially be used for decades, but some parts will experience wear and tear and will need repair or replacement, including things such as belts, bearings, and tires. You may also have to fix some broken welds and do engine repairs, but the bulk of the machine will last decades. All of the materials that go into the SIL multi-crop thresher have been found in local African markets. This includes things such as sheet metal, axles and wheels, angle iron, pulleys, engines, pipe, bolts, and nuts. Maize shellers are already commonly fabricated across the African continent. There are also some other organizations that work with multi-crop threshers, and we recommend any thresher, whether it be a SIL multi-crop or one of these other organizations. The ability to thresh something other than maize is incredibly important, not only to farmers, but also to food and feed producers who need to source grain. So some of the other multi-crop threshers that exist across Africa include Tech in Tanzania, Appiagyei in Nigeria, and the Africa rice thresher that's found in West Africa. Tech is a small company that sells in both Tanzania and Uganda. Their multi-crop thresher retails at about $700 US, meaning it will pay for itself within 70 hours of operation at about a $10 per hour income. So you can see that just as I showed in the SIL multi-crop thresher, maize has considerably higher capacity in the Tech thresher with 25 sacks per hour, where you get down to things like common beans, about 2 to 3 sacks per hour. The Tech thresher is shown at the bottom right of this slide and can be transported on the back of a motorcycle. The larger SIL thresher requires alternative methods of transport, such as oxen, tractor, truck, or cargo motorcycle. In 2019, we did field research to determine costs and income of threshers in Ghana. Labor was the biggest daily cost, with transport and fuel running a distant second and third. Average daily operating costs were determined to be about $38 a day, with labor comprising 55% of that. In Ghana, service providers usually charge 10% of the grain threshed, leading to a very high profit margin for maize, which has a high threshing capacity, and lower margins for soybean, which threshes more slowly. Overall, the net margin for service providers in Ghana was determined to be about $7,800 for a 75-day harvest season. The conclusion of this research was that mechanical threshing is highly profitable, and although there's currently not much competition in the market, margins will fall over time, especially once service providers and farmers reach the conclusions that prices for service provision should be more variable and based on crop throughput. At a 10% charge rate, maize threshing is likely overvalued, while soybean threshing is undervalued. As experience levels and service provision increase, systems will also evolve to improve efficiencies, such as reducing travel time, working with better trained and more efficient labor, and developing fair prices and costs. Our conclusion over the past 4 years of improving thresher access in Africa is that mechanical threshing reduces a serious bottleneck for sub-Saharan African soybean industry and can have significant positive impacts in grain sourcing for food and feed manufacturers. There are many places for food and feed producers to work with trained thresher manufacturers across Africa, including well-established fabricators in Ghana, including SayeTech. There's large-scale fabrication starting up in Ethiopia, and local industry by First Wave Panoply in Zambia and Amaratech in Tanzania. We have trained but are still working on manufacturing establishment in Zimbabwe, Rwanda, Uganda, and Malawi, and we have training planned in 2021 in Kenya, Nigeria, Senegal, and Sierra Leone. To find out more about where you can source the SIL multi-crop thresher, you may contact us at the address on the slide. SayeTech is our major and most established commercial partner and has been on the development process of the SIL multi-crop thresher since day one. This company, headquartered in Ghana, provides manufacturing services, design, threshing service provision, and monitoring software that allows tracking of the equipment's location and running time. SayeTech works with commercial clients, including food and feed manufacturers, aggregators, and processors. For example, they work with the Yeading Group of companies, which provided thresher services to farmers in order to receive soybeans without stones for their food processing. They've worked with Appiagyei Aggregation, located in Yendi, Ghana, which threshed and gathered over 140 tons of maize and soybean in one season with a multi-crop thresher for their farmers. And Vinchem Farm Supplies acquired threshers to deliver clean soybean for their overseas buyers. A feed manufacturer that has engaged with Soybean Innovation Lab and the multi-crop thresher is First Wave in Zambia. First Wave Group is Africa's leading aquaculture firm. They sustainably provide an abundant supply of affordable protein to the growing African community through aquafeed, fish production, and distribution and retail of fish and feed throughout southern and eastern Africa. 90% of their aquafeed production inputs are sourced locally, with soy constituting about 50% of the fish feed. In 2019, they conducted a 3-month-long field study on smallholder soy farming in central Zambia to understand the challenges faced by smallholder farmers in the soy value chain. They identified a need to improve harvesting and input technologies to increase soy harvest yield and quality. First Wave introduced a fleet of multi-crop threshers as a solution to address needs for improved harvest techniques used by farmers, also to ensure that First Wave can procure the needed tonnage of grain each season, and to train local blacksmiths and engineers to build and maintain multi-crop threshers. First Wave partnered with the Soybean Innovation Lab to conduct thresher fabrication training in Zambia, with a total of 17 threshers manufactured in the beginning of 2020. First Wave examined 3 different models of thresher ownership and utilization, the first being provision of threshing services, where First Wave provides the service directly to farmers. The second is a lease, where the unit is leased to a third-party service provider on a fixed monthly rate, and the third being sell, which can be for cash or barter with grain. First Wave's cost of producing a unit thresher in Zambia was approximately $3,300 US, with materials and parts being a little over half of that, the engine being around $815, labor around $350, and then recouping training costs about $400. So they're expecting as they go forward that the cost will reduce to under $3,000 US as training is paid off. First Wave also analyzed their daily revenue with threshers and found that, like in Ghana, maize is the most profitable. They did not charge as much as most African service providers, with an industry norm of 10% of grain threshed. Because First Wave's goal was grain procurement, they charge only 2%, thus the threshers, especially with slower throughput crops such as soybean, showed lower profit than in Ghana. However, in both markets, maize was shown to be vastly more profitable for service providers than was soybean. Variable pricing rates based on throughput can improve profitability for service providers, especially in low throughput crops such as soybean. First Wave found that the service provision model was the most profitable for them, and that they were able to recover their initial investment within the first 3 months and then continue to generate more profits thereafter. The fixed leasing option was also found to be viable, but had less of a guaranteed market and less of a permanent client base as that under the service provision option. And finally, the sales option appeared to be the most lucrative. However, small-scale farmers are unlikely to be able to afford the threshers, and it's most likely that they would be sold to service providers. First Wave is currently producing, First Wave and Panoply are currently producing the units at about $3,300 US and selling at about $4,200 US, giving a profit of around $870 per unit. Lessons and recommendations that the Soybean Innovation Lab has developed over our 4 years of thresher research. One is that mechanical threshing vastly improves grain quality. 2 is that processors and buyers can better guarantee an adequate grain supply for themselves by investing in thresher access for farmers. And 3, this access can be provided by in-house or third-party service providers. Thank you for joining us today to hear about local fabrication of multi-crop threshers in Africa. And now we would like to take any questions that you all may have.
Well, Kerry, thank you for that excellent presentation. That's really amazing progress in such a short period of time in developing this technology. So congratulations to you and your team. I had a question. I was looking at the picture of the hand threshing, and it reminded me of something in my past where I'd seen workers who were doing hand weeding with short-handled hoes. And in those studies related to that work practice, there was a significant challenge with physical injuries, back injuries of the workers, to the point where that was studied and documented, where basically in many locations the use of short-handled hoes for weeding was outlawed because it was causing too many worker injury issues. And it certainly seems that the availability of the thresher would, you may have similar, by hand threshing, you may have similar problems, and the introduction of your thresher would certainly eliminate that. Has that been looked at all by the chance as an additional benefit to using the thresher?
Yeah, I mean, the reduction of drudgery is an important part of using the thresher. When we first started, when I first started with SIL, I was actually not doing threshing. I was doing a seed distribution. And people were telling me that they didn't want to grow soybean because it hurt too much to thresh it by hand. And that was sort of the beginning of this whole Thresher project when we started hearing replies like that.
Oh, that's really interesting. Well, I think that sounds like a significant benefit in addition to the obvious economic benefits that you've shared with us. So it also seems like your project is a work in progress, and you've been making modifications and improvements almost every year to this technology. So is there any new changes in the works? Anything you can share with us on future plans for the thresher?
Yes, we're going to be adding grain monitoring. So it's already, if you buy it from SayeTech, it's got GPS monitoring.
Very good.
And the owner operator is alerted via an app when the machine is running. But we're going to add grain monitoring to that so we can actually capture yield as well.
Oh, that's fantastic. That'll be a great benefit. Well, terrific. Thank you so much for your presentation. So our final speaker of the day is Eric Lane. Our final speaker of today is Eric Lane. He's the co-founder and principal of Prosperity Systems in the United States. His talk is entitled Low Cost All-Terrain Truck and Tractor Platform to Address Constraints in Rural Production, Sourcing, and Processing. Prosperity Systems is a project to develop a low-cost multi-purpose all-terrain farm vehicle for Sub-Saharan Africa. Eric leads business and project management and informs vehicle development in collaboration with advising experts at the forefront of developing region small-scale mechanization. Prior to Prosperity, Eric conducted technical research, communications, and advised strategy for Edison II, a hyper-efficient vehicle project now in the Henry Ford Museum. Prosperity was co-founded with Ron Mathis, Edison II's chief of engineering, on the principle of applying world-class engineering to sub-Saharan challenges in transport and food production. After Mr. Mathis died in a tragic accident, Eric rebuilt the project with partner Chorus Engineering, developer of the world's first all-terrain supercar. The project is currently positioned to complete development and build vehicles for evaluation in destination countries. Eric, welcome, and the floor is all yours.
Thank you, Patrick. I'd like to thank Annette, Amy, Ellen, and Juan, and the rest of the team for their outstanding speaker support, as well as AOCS and their partners for bringing us together today. I'll be talking about our farm vehicle for rural agriculture and how it can address constraints in production, sourcing, and processing. This is something that we're calling the Service Rover Vehicle, or SRV for short. This is a vehicle that can be configured as a transport truck or an agricultural tractor, or both in the same day if needed. It can till, plant, pump, spray, harvest, and process crop on highly variable terrain, and it does not need a road to haul a crop. I'll be covering these three topics, but before I start, I'd like to clarify that what we've done is we've completed the technology development and the engineering, and what we're doing now is pursuing funding to build vehicles and put them to work as soon as possible in destination countries for evaluation. Today, we'll be talking to the Ministry of Agriculture for a country, so there is interest in what we're doing. So starting with background, The project is founded on the principle of applying world-class engineering to a developing region problem. It was co-founded with Ron Mathis here, a world-class motorsport engineer. He also led mechanical and structural engineering for this rocket spaceplane project, designed this hyper-efficient vehicle now in the Henry Ford Museum. And here he is sketching an all-terrain vehicle for Africa. This was a big passion project for Ron. Unfortunately, as the biography said, he was in a tragic accident late 2016. He died a month later. And we were fortunate enough to continue the project with Dimitri Kores from Greece, a gifted multidiscipline engineer. He designed the world's first all-terrain supercar. He does specializing engineering for projects like the suspension bridge. And here's his sketch for an all-terrain farm vehicle for Africa. Now, they say that the best minds think alike. And these world-class engineers, they never actually knew each other. And yet, they had arrived at exactly the same conclusion on the core suspension architecture. And it was something that no one else was doing. This is when I felt like we were onto something. The project is also founded on the research literature from these and other organizations. The review of the literature was broad, around 4,000 pages on sub-Saharan infrastructure, mechanization, and farming. At the highest levels, we found the most conspicuous thing, something most of you are familiar with, this great disparity between food demand and agricultural power to produce food. Now, what's not on these charts is that yields are going up thanks to improved seeds, inputs, agronomy, the kinds of things we'll be talking about over the next 10 days. Also, demand for greater quantities of high quality crop are also going up thanks to efforts to connect farmers to buyers. The one thing that isn't going up is farm power. Around 60% of farm power in sub-Saharan Africa is human power, cultivating with hand tools, as many of you know. This makes the urbanization graph very concerning. In the middle of this relentless rising demand for agricultural power, the human power, the largest source of farm power, is draining out of the system. This is why machines like SIL and SayeTech's multi-crop thresher and the programs to build it are so into the ground, feeder roads degrading, these changing weather patterns working against the farmers. In those bullet points here, we can see some of the key challenges that are facing these farmers and that therefore impacting production, sourcing, and processing. A lot of processing facilities operate below capacity a significant portion of the year. So we wanted to understand, beyond farmers not having money for machines, what was perpetuating this vacuum in cultivation technology? And what we found again and again across the research were what appeared to be these three key drivers. Now, the lack of good roads constrains economic activity as well as access to essential machinery. And the machinery was either large four-wheel tractors for industrial farming or small two-wheel tractors that were ideal for small-scale rice farming, or tractors built for very flat land, smooth roads, short distances. And some of the rural farming systems in sub-Saharan Africa are like this, but a great number of them are not. And if machinery was brought in, the supporting infrastructure was so weak, the technology couldn't be sustained. Tractor losses are very high. Just look at Nigeria's tractor rehabilitation program here. It's an indication of the magnitude of the problem. And if you look closer, those are not the same tractor, not the same engines, or the same parts inventory. That's a huge undertaking. Now, we knew that we couldn't solve these problems ourselves. They've been going on for more than half a century. But what if we could engineer a way around these constraints and use the research as our guide? So this is what we came up with, a solution set. going from top to bottom, getting around the road issue by engineering a vehicle that doesn't need roads, getting around inappropriate machinery with a machine that is low cost, appropriate power, very versatile, get around machine support by engineering the machine to be simple enough to be built and serviced and supported in rural regions with a low investment approach. And another thing that we saw consistently was the importance of including and empowering women and youth, making agriculture appealing to the youth. This is something that's become more and more critical. Now, a benefit of building the solution set from the research is that when development strategies were launched in 2018 that were also built from the research, we discovered our solution set was already very closely aligned. These colored bars are some of the recommended strategies for agricultural development that we address. These were launched by the FAO, the African Union Commission, the MAMO panel. They're designed to help donors and their recipient countries meet agreed development targets. Many of those targets are focused around the Sustainable Development Goals. These are 4 of the goals that we're aligned with. They're actually aligned with more than this and more than these strategies, but we're just using these 4 as an example. All of this is a really high level perspective. And we will be taking a closer look at each of these strategies in detail and how we align with them. But for now, let's get down on the ground and let's look at our solutions in an agro-processing context. Here's an example of the SRV configured for thresher transport. So farm level agro-processing. We'd like to thank Jeffry at SayeTech and SIL for sending a CAD of their multi-crop thresher. With a few modifications, their thresher can mount in the rear cargo area of the SRV and be powered by our engine and power takeoff. This reduces the build cost of the thresher around 30% because you don't need the $800 engine or the trailer or the wheels. And this combo is an all-terrain crop processing solution. The SRV can move surprisingly fast and smooth over rough roads and rugged terrain. If the roads are more conventional, a second thresher can be towed, and that can be powered with our engine, again, using the front PTO. So we'll have front and rear PTOs around 30 to 40 horsepower to work with. Now, a crop like soy takes longer to process, as we learned. This setup doubles the work capacity to help compensate for that. And the important thing here is that it's all being done with one engine and one platform without having to maintain 2 more $800 engines for the threshers and all of their parts. So this is reducing the parts and service logistics down to a single parts inventory for a single engine type and a single vehicle type. Here is the SRV configured for crop transport. That's a conventional trailer. Without the trailer, it's an all-terrain solution that can actually transform farmer access to market and reduce transport cost. With conventional vehicles, transport cost on degraded rural roads is up to 4 times the cost of transport with a paved road. These are 50 kilogram bags, 24 in the SRV at 1.2 tons. It's kind of misleading because the truck bed actually goes down 2 to 3 more feet. 35 bags in the rear for close to the rear trailer for close to 3 tons of transport. These are estimates. We can also design an all-terrain trailer. The top speed with our gearbox, which is designed in-house, is around 55 kph, 34 miles per hour. Now, a typical question we get is, what is the size of this vehicle? Here it is compared to other commonly used platforms. That's a Toyota Hilux pickup, a small 2-wheel tractor. As you can see, there is a gap that can be filled here, but only with a vehicle that's highly capable and versatile. So let's explore that. So let's look at how our solutions align with recommended strategies that we saw earlier. Here's the first recommended strategy: overcoming these last mile road constraints, addressing this last mile infrastructure constraints. There's a lot to look at. I want to focus your attention on the white vehicle over here. The SRV uses a very simple adaptation of our partner's all-terrain technology. That technology is the result of 4 prototype vehicle programs, over 3 million spent. It's proven across all of those platforms. It's doable, it's durable, and it works. And I'm sure some of you are probably wondering, what does an all-terrain supercar have to do with rural farming? What it has is high flexibility, which gives us very high traction on all 4 wheels, much lower chance of getting stuck. It has an interlinked suspension. The suspension helps to keep the vehicle level and stable, as you can see in that image there. The SRV with this system can access nearly any farm and haul a crop without a road. Of course, getting to the farm is only half the problem. The other half is being useful when you get there. So it can be converted to a multi-purpose tractor that can operate safely on slopes up to 35 degrees, grades up to 70% with up to a 1.2 ton load. So this is a vehicle that can go farm to farm in rural farming communities without needing a road. There are significant implications to this. I could quote a lot of data, but basically road infrastructure is very difficult to fund and to maintain, which begs the question, why build a road in an area without the economic activity to support it, when vehicles can be built that enable economic activity without roads, economic activity that can help support future infrastructure? So by leapfrogging infrastructure, the SRV can actually help to act as a bridge to help enable future infrastructure. Something to think about. The second recommended strategy, in a nutshell here, a lower horsepower tractor can do a greater variety of jobs, drudgery reducing jobs. So these are a few sample configurations. Many other configurations are possible. These configurations target labor reduction. These are profiles of implements in the same power range that are in wide use. We had to model them so they're not engineering perfect, except the Thresher, of course. Now let's look at the features. A diesel gearbox and powertrain, so it's like a conventional vehicle, but it is engineered for a tractor application. You could stop right there and just have a great all-terrain transport vehicle. The rest of this these are all add-ons. So hydraulic hitches for the front and rear, very small, very low-cost system, compatible with Category 1, 3-point implements, front and rear power takeoffs, optional generator, optional compressed air tank. So what you're looking at here is more than a multi-purpose tractor. It's a mobile power delivery platform providing 4 kinds of productive power into these deep rural areas. So in some ways you can think about it as portable infrastructure acting in the place of roads, providing mechanical power, electrical power, air power for pumping up tires, other uses. So in summary, the right machine can do more jobs. That equals more job opportunities. Those job opportunities are the foundation on which to build a mechanization services industry. At the core of that industry is the third strategy. They need to build and service machines locally. I'd like to take that a step further and say the need to integrate local build and service of machines into the crop sourcing industry. So to do this, we need to engineer to a few basic principles. A very modular, very efficient design that's easier to build, using common components. These are technologies that are already proven, they're already in wide use, they're understood, simple, rugged, low cost, and having configurable vehicle kits based on the capacity of production on the ground. A vehicle like this can be produced in modified container facilities. These can act as standardized turnkey systems. As we learned, the locally made Thresher was half the cost of imported Threshers. Also, they're doing Threshers as a service. So they're making recurring revenue off the same machine year after year instead of just building and selling it. And we were actually delighted to find that they had reached the same conclusion we did, which was very encouraging. Now, these facilities can serve over here on the right as infrastructure for vocational training, local manufacturing capacity, and a system that can work for franchise production. Everything over here on the right, these are all coming from, these are direct recommendations from the recommended strategies. So those are the strategies in more detail. Now, all of this plays really well into the last recommended strategy, empowering women and youth. This and the strategy before it create all of these programmatic opportunities, especially if the vehicle is designed for gender agnostic use. Now, all of these programs can be focused on attracting youth to agriculture. These programs already exist. There are a lot of tractor training programs out there. This is CIMMYT, the International Maize and Wheat Improvement Center, two-wheel tractor driving training. You have here, courtesy of SayeTech, SIL, their fabrication program is now in seven countries. Now, these programs, however, they tend to be siloed, and they tend to be within siloed technologies. We believe the SRV can act as a catalyst to help integrate and focus programs and technologies like these around a common platform, kind of like a hub and spokes situation. So this covers our solution set. I'd like to start wrapping up by summarizing the implications and competitive advantages for aggregators, processors, and outgrower operations. You're looking at farmers accessed here. You don't have to go very far when you're not constrained by roads. You don't have to go very far to triple the number of farms you're accessing. In terms of the quantity and quality of sourced yield, as most of us know, with appropriate inputs, especially appropriate mechanization, you have sustainable intensification and extensification, increasing the land under cultivation. So this is a conservative figure. For efficiency gain in production and logistics, unlike conventional vehicles, like I said, the SRV can move at this surprising speed over rough roads and terrain because it's not bouncing up and down. It's the way the technology is designed. So that means that the forward momentum of the vehicle is preserved. In summary, in short, that means you're going faster, but you're consuming less fuel doing it. I just read a study that showed that transporting crop with a truck is half the cost of transporting with an animal cart and 1/5 the cost of transporting crop with a motorcycle. It's one of the only studies I've seen of its kind, 2014, from the Africa Community Access Program funded by UKAID. So we expect to pick up efficiencies in cost and timeliness in transport, cultivation, harvest, post-harvest processing. It's a compounding effect and impact. Contrasting, we look at the larger four-wheel tractors here, and a lot of us are familiar with this. They're limited in farm access, tend to be restricted to just land prep because they're so powerful. They're kind of overpowered for doing this smaller drudgery work. And if we want to reduce drudgery, more machines are required. So you have to have transport, small engines, etc. Now for service providers, people who are owning and or operating machines, in the green box here, these are estimates from about 6 years of economic data that came from CIMMYT on the two-wheel tractor. We anticipate doubling the income hours over a four-wheel tractor and doubling the income hour over a two-wheel tractor. I can get into details on that later. The FAO research is showing that a four-wheel tractor in Africa, the utilization is a huge challenge. So target utilization for viability is recommended 800 to 1,200 hours. They're only at 35% of that per the FAO. This is another big contributor to tractor losses. What we've done is we're working to engineer the SRV to minimize the fixed and variable costs while maximizing income throughout the cultivation cycle. Now, for initiatives that are promoting mechanization, there are big advantages to a one engine, one platform approach that doesn't require roads. The alternative, you're dealing with trucks and their engines, tractors, their engines, small engines for processing, pumping, etc., and building more roads. This picture here is from Rwanda just this past month. That's a road being built by hand. That came in from the founder of Pride Farms. They're one of our strategic alliances. They're the fourth generation farmer providing mechanization services in these rural areas. They said if they had the SRB tomorrow, it would be too late. We need to get these on the ground as soon as possible. So here's a quick look at the team. Myself, Cora's Engineering, that has their own team of fabricators and draftsmen. We are well represented in agricultural advisors, specifically in smallholder mechanization across some of the premier research institutes. Dick Tinsley, Crop Systems, 15 countries, also some private industry expertise as well. Well represented in business development, 2 NASDAQ offerings, these other companies, Startup Accelerator, a long list of affiliates from the supercar program that can solve any technical problem. We're building that up in agricultural companies as well. Here is the project roadmap. I'm going to skip the details. We'll just go over the basics. We're going to build and evaluate vehicles, work to localize the technology, localize the manufacturing through the kinds of facilities and support I talked about, transition to local vehicle build and service, provide with partners, ongoing support and scaling. So this is a technology transfer program to achieve these kind of objectives over here. We believe this is the kind of approach that needs to be done if we hope to get to this point. So finally, our closing case. I have described in detail how our solutions are aligned with development strategies, and as a result, being aligned to development goals. They're also aligned to these ecosystem development efforts and solutions, looking at transport, infrastructure, agricultural productivity, mechanization, in-country manufacturing, vocational training, engaging the youth in agriculture, entrepreneurial efforts, all of that. We are intentionally designed to be a good fit into those different parts of the ecosystem. Now, if this was easy and highly profitable, it would not be a bold solution. It's actually a bold solution, and these kinds of solutions need bold, visionary support. So this is our call to action. If you're engaged in initiatives or corporations that are actively pursuing solutions for rural production logistics, whether it's infrastructure, mechanization, engaging the youth, expanding products into these rural markets, or expanding the export of products from them. If you're engaged in these or know someone who is, would greatly appreciate referrals. We're happy to do this presentation and start an opening dialogue. And that's the end of my presentation. Thank you for listening. Thank you for your interest. Our visualizations are courtesy of Sketch Tank Environmental Design in Los Angeles. You can get in touch with them through me. My email there, e.lane@Prosperity Systems. That's prosperity with an A. Thank you very much. I'd like to open up for questions.
Well, Eric, thank you for that that presentation. I sure want to get my hands on one of those vehicles. They look amazing. You mentioned that towards the end of your presentation, you mentioned the sort of 4 phases of development and deployment. Where are you now? What phase are you in now?
We're there in the first phase.
First phase. And what do you think, ideally, the duration to get you through the 4 phases? How long do you think that'll take to see what's your vision on how long that'll take to see getting through all those 4 phases?
All 4 phases. That's a good question. There's a lot of variables, but I could see that happening in 5 to 7 years. You know, depending on the kind of countries, the kind of people that we're dealing with. The amazing part is getting the vehicle on the ground. That can happen in around a year. So the engineering partner, they've already done this 4 times before. So they're very fast and agile, and that's a huge advantage for a project like this.
That's fantastic. Thank you. I'm sure we'll have more questions here in the panel discussion. So I'd like all the speakers today to now join us for the panel discussion. And for the audience, again, please submit your questions using the chat feature. And if you can remember to identify which speaker you want the question for, that helps us sort of make sure we get the question to the right speaker. Otherwise, we put it just to the panel itself. So in 1 minute, we'll have everyone back. Well, welcome back, all the panelists or speakers for our panel. Today we have questions that have been submitted by the audience, so we'll kind of go around and put the questions out to see how we do here. So Baljit, I did have a question. A couple questions came in for you about your Phi protein here. What about allergenicity? How does it compare to soy and egg protein?
Yeah, thank you, Patrick. It's a great question. As we look at new ingredients in the alternate proteins area, that is the first question that comes to our mind as a scientist as well. And for Phi protein, we have done extensive research and study on the product, and it does not contain any allergens that are known to us. So yes, so obviously the product has gone through a lot of testing. And we also know as a scientific community that, you know, proteins, whether it's milk proteins, soy proteins, over the period of thousands of years of consumption, they develop allergen. They develop the allergen as you use protein more and more. So that we have to keep in mind as well.
Great. There was one other question about Phi that came up about the quality of the protein. I know you said some mentioned it in your presentation, but the question is, you know, what was the quality of the protein? Was it, did you assess that through PD-Cas or digestible indispensable amino acid score? How was that assessed?
Right. So that's another great question. I mean, proteins, as we look at alternates to meats and other animal-based products, animal-based products has a perfect digestibility score. They contain all the 9 essential amino acids and has other essential nutrients as well, like, for example, vitamin B12. So Phi protein contains all of those 9 essential amino acids that are found in meat-based proteins, and also contains vitamin B12, which is very unique as you look at other plant protein sources, which does not contain those vitamins B12, for example. And there's another thing I'll mention about that, even containing the 9 essential amino acids. That's the one thing which is very, very important. But also the quality and the content of those proteins. The bioavailability is very high. We have tested using the models, and it's showing a very, very high digestibility scores and bioavailability, just equivalent to that of meat proteins. Lastly, on the branched chain amino acids, which are essentially, you know, found in animal proteins, like whey protein, for example, which is very high in leucine and isoleucine, which are the branched chain amino acids which are linked to the muscle growth, used heavily in sports nutrition and things like that. So Phi protein also contains 20% more of the branched chain amino acids than compared to, for example, soy proteins.
Very good. Thank you. Andrew, we have a question for you. It looks like, does the oil and protein change for a variety with the growing conditions in any season?
Yeah, absolutely. There's a significant genotype by environment interaction with soybean seed composition, protein, oil, as well as constituents, fatty acids, amino acids, as well as soluble carbohydrates. And I mentioned it a little bit in the presentation, but a lot of that has to do with temperature and nutrient availability during the seed maturation stage. So when soybeans are filling the pod and the seed is developing and nutrients and things are being translocated to the seed from the plant, that process is driven, like all biological processes, with temperature and nutrient availability. And that can be dependent on the specific genotype. So yeah, in the data we showed, it's 8 percentage points difference in protein, which is very dramatic. We may not see that much of a difference here in the US, but we're dealing with a lot different environmental conditions there in Sub-Saharan Africa. So,
right. Well, another question, Andrew, is when will farmers have access to improved seeds? You knew you were going to get that one.
Boy, oh boy, oh boy, that is the question. The Soybean Innovation Lab itself was initiated in 2013. And there just hasn't been a lot of research, both on the breeding side as well as the fundamental management side of soybean in Sub-Saharan Africa over the last 50, 60 years, relative to like research and things that are done in the US, right? So not only are we behind in yield potential, but we're just behind in research. But with that said, over the last 6 to 8 years, we have made a lot of progress in a lot of different countries. And I'll just highlight the International Institute of Tropical Agriculture, IITA. They have one of the best soybean breeding and variety development programs in the whole of Africa, in a public sphere. And then I'll also highlight the company Seedco. They have had a big push in the last 10 years for developing soybean varieties. So I'd say, the soybean varieties that are developed in conjunction with the Soybean Innovation Lab, like you saw, they're being registered currently. So they're available, but I'll mention one thing, part of the value chain that is missing is the quality certified foundation seed that a farmer's going to grow. Like producing that seed in Africa is a big challenge, because of different environmental conditions. Producing high quality seed that has a high germination rate that you can hand off to a farmer and they can plant and get good plant stands, that is a huge challenge. So developing the soybean varieties, it's there. The private industry is there with Seedco, the public extension efforts, things like that, they're all there. I think what's a big part that's missing right now is how can we produce that seed that a farmer is going to grow, a high quality seed that a farmer can buy and get a good crop. So,
all right.
Maybe that's a long-winded answer.
No,
but
that's great.
The varieties are there, but there's a big, that last step to producing high quality seed is a challenge.
So we have another question, Andrew, for you and Liz, I guess. And is the protein and oil analysis available in Africa for seeds in the market?
Let's see. So currently, we do a lot of the seed all of the seed composition analysis here in America for the Pan-African trials. The technology is there in different countries as far as wet chemistry technology, GC, HPL. There's a few different labs. Some of the NIR technology is there, but it's just not as robust as it is here in the US. But I will say part of our mission, similar to what Eric, has talked about, we've also done a lot of mechanization to build capacity within the breeding programs, but also on the lab front, not only for genotyping, but for NIR. So part of the next part of SIL is going to be introducing NIR technology to the breeding programs so they can utilize it for the programs to develop better high-value soybeans. But that question also leads to the fact that right now farmers, they do not get paid for the amount of protein or oil in their soybean. They get paid for the amount of seed that they bring to sell, right? So the value, the need for this type of technology in the industry is not as crucial as it is maybe for a processor, so maybe the processors see the value in understanding protein and oil composition in the seed that they're processing, but all other parts of the value chain, not as important, right? So,
right.
Yeah.
I know in some segments in ag, the NRI technology has gotten quite good and scaled down, and there are handheld units for certain compositional characteristics and specific crops. Do you know, is there anything being done in soybeans in that area?
Yeah, absolutely. I'll talk a little bit about westernized agriculture. If we go to a component-based system where farmers do get paid for protein, they do get paid for the oil, I envision a farmer having a NIR on the combine, and that those are available now, to where a farmer is maybe not looking at total yield, but they're looking at the protein and oil across their farm, where different management strategies that can affect increasing the protein or increasing the oil. And there's a wide range of NR technologies, like you said, anything from a handheld to a $150,000 machine that does extremely precise things, that a handheld unit couldn't do. So they're available right now in westernized agriculture, but like I said, I think even in the US, farmers don't get paid for protein, right? Unless they have, there's certain niche markets with a contract where, it's kind of a closed loop value system. But overall, farmers in the US and westernized agriculture get paid for how much grain they bring to the elevator, not how much protein they bring. But that could change, to Baljit's point, our keynote speaker, and Eric, that as protein becomes the value, a component system may work. And the last thing, I'll be quiet, what's driving soybean in Sub-Saharan Africa, I think, is the poultry industry. For the most part, there is a lot of subsistence value to soybean, but, I think what's driving is the edible oil market and the protein for the poultry market, and those are important concepts to understand in the value chain when you're developing varieties.
Very good. Thank you. So Eric, we have a couple questions came in for you. What has been done in post-harvest, cold line, drying, milling, packaging, etc. applications? We have observed that multifunctional equipment works better for small size companies.
Okay, can you read the beginning of that question again?
What has been done in post-harvest, cold line, drying, milling, packaging applications? Have we observed that multifunctional equipment works better for small size companies?
Mm-hmm. So this is in terms of what else can the vehicle do as far as post-harvest. Okay. This is something that it's in the realm of the entrepreneurs developing machines that can interface with ours. we're focused on the machine itself and creating it to interface with as many types of implements as possible. So equipment like this very specific, making it having the kind of equipment to do the things that the question asker is talking about. I think that is definitely in the realm of the machine producers, but we want to be able to interface with as effective equipment as possible. That would be my short answer.
Right. Do you need the modified container facilities? Is that requisite to start manufacturing at a location?
It's a very good question. I would say that we can be flexible with all of that. There may be places that have facilities that are even better than what a portable facility might offer. They may have a great deal of more space. They may be near very consistent power infrastructure. What we're trying to do with this portable approach is to create a sense of some standardization and some consistency. And that's one of the things that tends to be lacking in Sub-Saharan manufacture. So by providing a turnkey system, we're essentially working toward making that easier and more doable. But if there's already capacity, that's why we want to create a lot of flexibility in how we approach the manufacturing. If there's already this great capacity, they already have the tools, we just send them the system for being able to manufacture it. I hope is that helpful?
Great,
okay.
Thank you. Another question for you is, how far are you already with your technology? Could we arrange an assembly plant for SRV in West Africa, for example, in Ghana?
Yes, that can be done. Long answer. The long answer short is yes, that can be done. What we're doing now is we're in the process of, as I mentioned, pursuing the funding to build vehicles. We need to build them and evaluate them. But as that is happening, we can already be working in parallel to establish some of this on-ground stuff. And this is like your question earlier, Patrick, where how long would it take? If we can do as many things in parallel as possible, we can really shrink that overall timeline down so we can get the technology transfer, the on-ground manufacturing happening as quickly as possible.
So another question that came in is, what's the cost of the vehicle and or payback period of the investment for processors?
This is something we're working on in terms of the detail. I would say that a great place to have the pricing on this is around the cost of a used rugged tractor. That would be the cost. So we're looking at, if we can get it below 12,000, that would be great. If we can get it below 10,000 for a built cost. And a lot of it depends on how much building you're doing in country, how much of your materials you're sourcing locally, the cost of those materials. There's many, many things involved. But the hope is to get it down to this very, very competitive price, especially if you're making it in country with as many locally sourced materials as possible. Hopefully that helps.
Another question, Eric, that came in is who to contact to get the mechanization rolling. So, somebody wants to buy. So who do they contact?
They contact me.
Right.
e.lane@Prosperity Systems. And we already have a contract on the table to be able to build some of the first vehicles. We're exploring as many options and opportunities as possible. Like I said, we're speaking with the Ministry of Agriculture today, and they seem to have an interest in doing vehicles in country as well. So yes, all doors are open. And as I said before, I'm happy to present to anyone who is interested in moving forward with this.
Very good. Baljit, how do processors begin to educate consumers in developing markets on the needs to prioritize foods of higher nutritional value? Whom do you bring in as a partner to communicate this? We can make it, but will they eat it or even try it?
Right. No, I think that's a great question. We have seen that, consumer prefers food choices, they will always go back and buy it again if it tastes good. So the product that is tasty as well as healthy is important. There are also consumers who will want, a little bit more than just taste and health, and that is about sustainability. And that is also about convenience, also about cost. These are all important factors in a food choice. But at the end of the day, if the product does not taste good, consumer is not going to buy it again. They will try it once, and after that, they're going to look for another one that may taste better. So in this, it is a it's not only just about nutrition, it's about taste. And I think this is where we need to have more and more research done on how to build better textures and taste profiles using these new ingredients, and also educate the consumer on why these are better for the sustainability, for example, so that consumer can buy these products, and they, while they're also supporting the climate, reversing the climate issues. So one of the report I was reading that Gen Z, who is our new generation, they're already saying that they will not buy any food in the future that is not better for the planet. And these kind of reports are already happening, or we're already seeing those. So I think the education is very important for a platform like this today. This is a great way to educate the industry, other partners in the industry, so that we bring that knowledge to the consumer as well.
Very good. Baljit, we have another question that came in for you. As you consider products for the market, do you look at available commodities or potential markets first? Are taste considerations for healthy snacks different from snacks that are non-healthy?
Correct. So I think consumer is looking for products that are nutritious. So definitely, as we look at from a Nature's Fynd mission, we are looking to bring nutrition in the forefront. And as we look at replacing meat products, we want to make sure we put the right protein back in, so that the nutrition is not compromised. And this is very, very critical. And consumers are looking for deliciousness as well, but compromising on nutrition may not be a good thing. For example, if someone is consuming a meal that is made using plant-based proteins, we need to make sure from a nutritional standpoint, it is delivering on not only just the protein content, but also how much of that protein is available as it is digested. So yes, it is very, very important for us to look at a complete nutrition as well as the taste.
Very good. So Liz, here's a technical question for you on your analytics. Are there equations for specific amino acids? How to obtain them?
So yes, for our calibration, the amino acids are included in those calibrations, with thousands of samples for those as well. We have seen that at least on our NIR system, it's not quite as high of an accuracy in prediction for the amino acids as it is for things like protein and oil, which make up a much higher portion of the seed. So those calibrations are available, but they are not quite as accurate as for protein and oil, for example.
Great. Let's see. We have one other question. It was a general question. I'll throw it out there in case anyone has ideas. It's not directly related to any of the specific talks. It's broader. How can I get enough information on training in North America to study deeply the subject of geopolitics and food security? So I know there's a number of universities that have programs in both geopolitics and food security, but it was a question that came up, and so I'll throw it out there to see if anyone has any thoughts.
Maybe I'll say quickly about, Good Food Institute has done a good job in bringing several of those topics, where food security is discussed, but also Good Food Institute, they're setting up offices in different parts of the world, and that is for a reason, so that sustainability and food security could have a global impact. IFT, AOCS, there's plenty of good information there as well.
Thanks for the plug, Baljit. Anyone else have thoughts on that before we?
I'll also mention the World Food Prize Foundation. We have conferences here in the U.S. and that might be a good interaction. I don't know if it's virtually going, maybe but that networking I think is a good opportunity to get involved with.
Right. Yeah, the Borlaug Symposium is every October, usually the second week in October. And this year it was virtual.
Yeah, that's right.
And
so that's another good opportunity to meet with the people who are interested in food security around the world. Yeah.
Right. All the thought leaders and influencers tend to be there every October in Des Moines, Iowa. So terrific. Well, thank you so much. I'd like to really thank our panel for all their hard work to put their presentations together and just gave us some excellent information and a lot of things to think about. I'd also like to let the audience know that there are a lot of resources of interest available on the AOCS website at aocs.org and on our online community, and that's at Inform Connect. That's the name of the community. It's at informconnect.org. And that online community has over 30,000 professionals and subject matter experts who you can ask and answer, and they can answer questions and share resources with one another. So I encourage you to take some time and go explore those resources, and hopefully you can find some answers you're looking for. With that, I'll bring this session to a close. Have a wonderful day and enjoy the rest of the symposium. Goodbye.